All right, so let's work one last example, and this one's going to be fairly detailed. We're going to have a lot of torques flying around, and we're going to have to do a very careful accounting to make sure we set it up correctly and solve the problem. So, it says a meter stick is placed on a fulcrum with its 40 centimeter mark resting on the fulcrum. A 3 Newton weight is placed at the 70 centimeter mark. A 5 Newton weight is placed at the 10 centimeter mark. If the stick itself weighs 2 newtons, where should a 4 Newton weight be placed to achieve equilibrium? Now, this is a problem where we want to make sure to draw a very good picture and label everything very carefully. So, let's start by setting up our meter stick. And over here, this will be 0 centimeters. This side would be 100 centimeters. We're placing the fulcrum not in the middle, but at that 40 centimeter mark. We are then placing a 3 Newton weight at the 70 centimeter mark, a 5 Newton weight at the 10 centimeter mark. So there would be about 10 centimeters, and that's going to be a 5 Newton weight. Over here-ish would be 70 centimeters. There is a 3 Newton weight. The stick itself weighs 2 newtons. Where do we put that? Well, that's its weight, that is gravity acting upon it. And we know that gravity acts at something's center of mass, which, for a uniform density, is right in the center. The center of a meter stick is 50 centimeters. And so there's the 2 Newton weight of the stick itself. That acts at the center of mass, right in the middle, the 50 centimeter mark. And then our question is where to place a 4 Newton weight. Where to place that 4 Newton weight? Well, for one, we don't even know if we want to put it on that right side or the left side. Let's kind of just do some accounting to start this problem off and look at our counterclockwise and clockwise torques. So, we know that tau is force times length. We're just going to do that again and again and again. Let's think about all of these lengths associated with all of these forces. So let's first label these things. I'm going to call this F1. It's working sort of left to right. F1, F2, and F3. And that 4 Newton, that's going to be F4. What are the lengths associated with these things? Well, remember the lengths are from the fulcrum. So even though this 5 Newton weight is at the 10 centimeter mark, its length is not 10 centimeters. The fulcrum is placed at 40 centimeters. The weight is placed at 10 centimeters. The length L1 from the fulcrum is 40 to 10, 30 centimeters. Similarly, our length L2, well, F2 acts at 50 centimeters. 50 centimeters is 10 centimeters from the fulcrum. And then lastly, if we go all the way to F3, 40 to 70, 30 centimeters would be L3. And L4, well, that's what we don't know. We're trying to figure out where it should be placed. That actually won't be L4 itself, but L4 will tell us how far from that fulcrum to place it. All right, well, so we've got all our forces and the lengths organized in nice pairs, all numbered accordingly. Now let's do some accounting. How much clockwise torque do we have? Well, what contributes to the clockwise motion? That's going to be spinning this way. Anything pushing down on the right side is clockwise. So it looks like we have F2 and L2, as well as F3 with L3. Those are our clockwise torques. What are our counterclockwise torques? Well, that's going to be things pushing down on the left side, causing this to spin counterclockwise. Right now that's just F1, L1, and we still don't even know where to put our 4 Newton weight. Let's look at what our counterclockwise and clockwise torques are. So clockwise, F2 times L2, we're going to have 2 newtons times 10 centimeters. And then F3 and L3, 3 newtons times 30 centimeters. If we add all this together, we're going to have 20 Newton centimeters plus 90 Newton centimeters for a grand total of 110 Newton centimeters of torque in the clockwise direction. For counterclockwise, we only have one force at the moment, F1, 5 newtons times a length, L1 of 30 centimeters. 5 times 30 gives us 150 Newton centimeters of torque. In comparing these, we can see that clockwise, 110 Newton centimeters, is less than the counterclockwise torque of 150 Newton centimeters. We can see that this needs more clockwise torque. Well, if it needs more clockwise torque, we're going to set that 4 Newton weight somewhere on the right to cause this thing to have a little more torque in the clockwise direction and ultimately balance it. So it needs more clockwise torque. We can ask ourselves, how much? How much more clockwise torque does it need? Well, 110, 150. We can see it needs 40 Newton centimeters of torque to balance. Well, that tells us that that's what torque we want to create, 40 Newton centimeters of torque. We know that that torque is going to come from F4 times L4. We know that F4 is 4 newtons. We know that we don't know L4, but we know that this torque should end up being 40 Newton centimeters. So to solve for L4, we divide by 4 newtons. We can see our newtons canceling. And L4 is equal to 40 over 4, which would be 10, and our units that remain are centimeters. L4 is 10 centimeters, but is that our answer? Do we put this at 10 centimeters? No, that would be counterclockwise. That's the opposite of the effect we want. This is 10 centimeters from the fulcrum. And what direction? We wanted to put it on the right to cause a clockwise torque. 10 centimeters from the fulcrum, which you can remember is at 40 centimeters. You want to place the 4 Newton weight at 40 plus 10 at the 50 centimeter mark. That is the answer to the question. 10 centimeters was what our math showed us, but that is 10 centimeters from the fulcrum. So where do we place it to achieve equilibrium? We place it right at that 50 centimeter mark. And that's about as complicated as we're going to get with torque, balancing multiple things on an object. And not only are we dealing with individual weights in this problem, we also had to take into account the weight of the stick itself, and we had to apply that weight at the center of mass. This is about as complicated as torque problems will get. Please feel free to email me if you guys have any questions about these and need further explanation. And as I mentioned in my announcement, I'm going to structure my Calendly to allow you to set up video conferences should you need additional tutoring or explanations of these things. You want to see a little more face-to-face interaction. So hope this has been helpful, guys, and I will be back next week with a series of videos on Chapter 8. Thank you.